Complex numbers.
Wait, my handwriting is even worse on this iPad.
Oh, I'll write for you.
Thank you.
Here, you write mine, I'll write yours.
Wait.
All right.
Shipley's handwriting is worse.
It's not going to be worse than that.
Write the sum or difference in standard form, which is a plus bi, without using a calculator. I really hope you wouldn't need a calculator for this anyways, but anyways, 2 in parentheses 2 minus 3i plus another parentheses 3 minus 4i.
This is a cheat code. My handwriting is so much better.
So when we have complex numbers, we need to treat them like terms. The terms that have an I get added or subtracted respectively, depending on what they are. And then the numbers without an I get added, subtracted, whatever, by themselves. So 2 plus 3 would be 5, and then negative 3 plus negative 4 with the i's would be negative 7i. So 5 minus 7i is the answer.
It's a sigma.
I'm good at this. You tried to do.
It's not working.
Did you push the button on the top?
Probably when you were trying to erase.
Yeah.
Nice.
All right, 4. 2 plus I, and then minus 9i minus 3. So you can do this one of two ways. You can either go through and say like 2 minus negative 3, which would be 5, or you can distribute this first, this negative sign, and do like 2 plus I minus 9i plus 3 if you feel like you need to do it that way. But as long as you're paying attention to the signs, specifically when they're being subtracted, you'll be fine. So then I've got I minus 9i, which would be negative 8i. So this is 5 minus 8i. And it's always got to be written in that form, because that's what standard form is.
No, the I does not switch the sign.
That's what the notes are for.
Mm.
I said that's what the notes are for.
I know, I should have done.
All right, number 6. Square root of 5 minus 3i plus negative 2 plus the square root of negative 9. What do we notice about this problem?
They're square roots!
There's square roots. What else?
There's only one eye.
There will be 2 options.
3i.
There's currently only one I, but what do we know about this?
That's a 3i.
That's
Two
illegal.
different versions.
3i, right? Because we can't have a negative under a square root. That's what causes an I to happen. So this is going to be square root of 5 minus 3i plus, over here, negative 2 plus 3i.
Isn't it also minus 3i?
Yeah, it should be plus.
There's not 2.
Because this is only plus. It's only if you take the square root of both sides, it's plus or minus.
So it's not plus, and then in parentheses, root negative 9. It's okay.
That's only if you have x squared is equal to 9. Or I guess I could do negative 9 in this case, and that would be x is equal to plus or minus the square root of, plus or minus 3i. But that's not what we had. This is just what's given to us. All right, so then combining stuff. I can't obviously combine, quote unquote, what's under a square root and what's not. So that's just going to be the square root of 5 and then minus 2. And then negative 3i plus 3i is just 0. So this is just my answer. Or you can write negative 2 plus the square root of 5 if you like it in that order better. It doesn't matter. Eight. I have to keep jumping. We've got the square root of 7 plus I squared minus 6 minus the square root of negative 81.
Wait, I squared is negative 1.
That was going to be my first question. Nailed it. All right, so I've got the square root of 7 and then I squared is -1, so this is going to be -1. And then over here, minus 6 minus, what's the square root of -81?
9i.
9i. So now I can combine this stuff. I only have one term with an I, so I only have to worry about that. But I've got square root of 7, and then I've got -1 minus 6, so that's -7. And then I've got to watch. I've got a negative here, and this is negative, so I've got to treat it like I've distributed, so it's going to be plus 9i. Now, normally in standard form, because it's a plus bi, we would put parentheses around that. If you didn't, I'm not going to take off for that. But that would technically be standard form, is to put in parentheses the piece that's like that. All right, so that's all adding and subtracting. So now we're going to get into multiplying. So essentially we're just going to be foiling, but there's going to be i's, or like the square root of a negative number, thus an I. So 10, 2 minus I times 1 plus 3i. So I just FOIL. So 2 times 1 is not the letter A. Okay, go away. Is 2. And then 2 times 3i would be 6i. Negative I times 1 would be just negative I. And then negative I times 3i would be negative 3i squared. So this negative 3i squared, what happens to this piece?
It becomes 3.
Yep, becomes positive 3. So I usually will just put a little arrow through it and write positive 3. So then I've got, still in standard form, 5 plus 5i.
But are we subtracting 3i squared? Or are we adding negative 3i squared?
We're adding 3.
Subtracting.
I squared is -1. Negative 3 times -1 is positive 3.
So it's negative 3, not just.
This piece right here
Yeah.
is negative 3 times -1, which is positive 3.
Okay. It's not minus and then the positive.
It would be the same thing,
Yes,
right?
it would be the same thing.
No.
Yes, it would, Daniel.
No, if it's.
Yes, it would, Daniel.
Negative 3 times -1 is positive.
Yeah. But
3.
if
There's
you
no
have-
other
I'm
negative
sorry,
sign.
who's talking? Alright, I'm
To
done.
her, not you.
Yeah. It's okay. It's fine. I just saw it differently.
All right, 16. In parentheses, we've got the square root of -2 plus 2i, and then times 6 plus 5i. So I have the square root of -2, so that means I need to take an I out, and square root of 2 is not like a perfect square, so I'm just going to have to leave it. So this is going to be I square root of 2 plus 2i. Now, if you want to write the I after, that's fine. I usually just put it in front so that it's clear that it's not under the radical, but that's purely just a notation thing. And then I can FOIL everything now. So I've got 6i square root of 2. Then I've got 5i squared. Whoops, forgot the plus. Square root of 2. Then I've got plus 12i. And then plus 10i squared. All right, so the terms that are I squared, I need to change their sign on them because they're going to become negative. So the 10i squared is going to become -10. And then over here, the 5i squared root 2 is going to just be -5 root 2. And then I'm going to be combining things together. So I'm going to get the things together that match up. So this is going to be -5 root 2 minus 10. And then plus, over here I've got the 6i root 2 plus 12i. Now, this isn't in standard form yet, so what I'm going to do is I'm going to factor an I out of both of these pieces so that over here I'm left with 6 root 2 plus 12, all in parentheses with the I, so that I'm written in, that's bi, and then over here, negative 5 root 2 minus 10, and I put that in the parentheses so that I have my a plus bi in the form there. Write the expression in the form bi, where b is a real number. So basically 20, we've got the square root of negative 5. All they want me to do is basically take out the negative from the radical. If it's a perfect square, then obviously we would take the square root as well, but this would just be I square root of 5 or square root of 5i. Just make sure that if you do it the second way, just make sure it's clear that the I is not under the radical. But again, that's just a notation thing. The book is going to write it like that if you're checking your answers. Find the real number x and y that make the equation true. So I've got 22. 3 plus yi is equal to x minus 7i. So if these are truly equal to each other, then whatever this is should be equal to this, and whatever this is should be equal to this. So that means that x is equal to 3 and y is equal to negative 7.
Wait, why not yi?
Because there's already an I here.
So you just get rid of it?
Well, you just don't rewrite it, because then that would be negative 7i if you wrote the I with it. Now, obviously, that one's pretty easy. They're not all going to be that easy, so a slightly harder one. 24
If you scribble something out and hold it.
x plus 6i equals 3 minus I plus 4 minus 2yi. If we have one like this, we need to take the stuff on the right and combine it first using the things that we did from problems 1 through 8 to combine them, and then from there we can find what they're equal to. So this would be x plus 6i is equal to 7. This is going to go against everything that you're used to, but y right now is just a number, and it's just a placeholder. It's not really a variable like it is, but it isn't. So I'm actually going to write this as minus 3yi.
Why do we keep
Why do you
learning
teach us
it?
something for 40 years? And then
This is going to be
freaking-
the only time all year that this happens, but we can combine them because we know that y is just representing a number. Y is not really a variable in this case. I know it's weird.
Why are we doing an example problem that we're never going to use?
We are going to use it on the quiz
I thought you said that it's never going to happen again.
outside of this section. Ordinarily, I can't do this because they're not like terms.
Wait, where did the 4 minus 2 go?
Your mom says.
I combined them. 3 and 4 are 7,
Okay,
and then negative 1
gotcha. Okay.
and 2, negative 3.
40.
So now I can have that x is equal to 7. And then for y, I need to take and say that 6 is equal to negative 3y, because I need these things being equal to each other. And so then negative 2 is equal to y.
how does that work if you, I'm gonna stop asking questions, cause I'm just confusing myself.
Thanks, Dan.
All right, I'm gonna assume, sort of, but not really, that you had the I squared, I cubed, I to the fourth in your notes, and so on and so forth.
Yes.
Okay, so obviously I is just I squared is -1, I cubed is -I, and I to the fourth is +1, just as a refresher, and then it just repeats the cycle. Then for I to the fifth is I, so on and so forth. But you could be asked a question like that on the quiz potentially for like what's I to the 27th or something like that. Find the product of the complex number and its conjugate. So 35 minus 6i. So what they're wanting us to do is take what they've given us and multiply it by its complex conjugate, which would in this case be 5 plus 6i. So we take it and we multiply it. Now, hopefully you recognize this to be a what?
Where?
Square trouble.
The other one.
Perfect square binomial.
The ones that
Starts with a
are-
D. Difference of squares.
Oh,
So then this would just be 5 squared is 25, and then the middle terms go away, so then -6i plus 6i is -36i squared. I squared is -1, so this is really going to be plus 36, and then 25 plus 36 is 61. That's your answer.
Are we done?
Nope.
Oh.
34, write the expression in standard form without using a calculator. I would be thoroughly impressed if you knew how to use a calculator to do these anyways. So I've got I over 2 minus I. So they want our answer written in standard form. Obviously, this is not currently in standard form. Anytime the bottom has an I in it, we're going to multiply it by its complex conjugate. Or if this problem was flipped upside down, we'd have to multiply it by I to get rid of the I on the bottom. Okay, so I'm going to multiply top and bottom by 2 plus I, because that's its complex conjugate. So on top, I end up with 2i plus I squared. On the bottom, it's a difference of squares, so I get 4 minus I squared. So up top, I squared is going to be -1. On the bottom, negative I squared is going to be +1. So I've got, I'm going to rewrite the order up here, -1 plus 2i over 5. This is not standard form, okay? Standard form is it split, which would be -1/5 plus 2/5 I. So it has to be split to be in standard form. I would say 90% of the points lost on a problem like this come from not splitting it at the end. The other mistake is just not multiplying by its conjugate. Otherwise, usually it's okay. So always make sure you split it up at the end. Just to give you one that would be like if it was flipped, 36. 2 plus I over 3i. So if we have this, there's no conjugate. The only time we're going to have a conjugate is if it's like either a plus bi or a minus bi, like on the bottom. So in this case, all I need to do is multiply top and bottom by I, because I need to get the I off the bottom. So I'm multiplying by I over I. And so then I get 2i plus I squared over 3i squared. I squared is -1. So on top, that becomes that. On the bottom, this becomes -3i, or not -3i, just -3. Split it, so I've got -1 over -3, or I can just say 1/3. and then minus 2 over 3i. And technically your I should be written after the number. If you were to write 2i over 3, I'm probably going to give it to you, but this is technically the way that you should be writing your answers, like that.
Shouldn't it be negative 1/3?
Nope, negative 1 over negative 3 is positive. Two more. 38. I've got 2 minus I times 1 plus 2i over 5 plus 2i. So my advice with a problem like this is not just immediately to multiply by the conjugate. Not that you can't, but I would recommend you FOIL the top first. Typically it will make it easier. If you go ahead and multiply by the conjugate, you're just going to end up super foiling in the end on the top, as I like to call it. So I would go ahead and multiply this first. So on top I have 2 plus 4i minus I. If you want to go ahead and write that as 3i just to simplify it down, you can. And then minus 2i squared all over 5 plus 2i. I would go ahead and combine this up here, so that's going to be a positive 2. So I've got 4 plus 3i over 5 plus 2i. Now you can multiply by the conjugate, which is?
5 minus 2.
Yep, 5 minus 2i. I would say a lot of times people get confused on these ones, and sometimes they do the conjugate of the top, but remember it's always the bottom because the bottom is what we are trying to cancel. And doing a difference of squares allows that to happen. So on top, I get 20. Where'd it go? Hello?
Shepard, what'd you do?
What is going on?
Y'all were all
It's
good.
on it.
He was trying to be secretive and y'all were like, oh, Shepard.
Nobody did.
I don't think this was on the whole time, but it doesn't.
It's still plugged in, right?
Yeah, oh, it's on. It's just not doing anything.
That was not even one of them. Yeah, but it had her name. Oh, no.
Okay, well, I don't want to spend the entire time doing this, so I'm just going to turn this off and I'm just going to pick up the problem on the board.